Hey guys, sorry I can't be here with you, but we're still going to be able to just kind of go through the test. This is what recording on smartboards is for. So my smartboard matches your notes. You should be able to follow along pretty easily just watching the video from your phone. So we're just going to go ahead and we're going to start filling in. We've been talking about, we talked about quadratic formula, and then we went in and talked about discriminants, and we talked about not being able to take the square root of negative numbers. Today we're going to talk about how to take square roots of negative numbers and how that applies to things called complex numbers and what those are. The very first little blank that we've got is sometimes we will encounter equations that have no real solutions. So we have to rely on the number system with the imaginary unit, indicated by the letter I. I means imaginary. Okay, anytime you see anything as far as an imaginary number, it's going to have I in it. That's how we know it's imaginary. We can take the square root of positive numbers like the square root of 9, and we normally say it equals 3 because if we were to go backwards, 3 squared is 9. Keep in mind that squaring and square rooting are inverse operations. They're opposites from one another. Technically, the actual correct answer to square root of 9 is not just 3, but also negative 3, so we say plus or minus 3. Think back to discriminant when we talked about the discriminant, or what was under the radical, was a positive number. We actually had two solutions. That is because when you take the square root of a negative number, or of a positive number, you get the positive and you get the negative. Think about it. 3 times 3 is 9, but negative 3 times negative 3 is also 9. So it shows up plus and minus. But when we try to take the square root of a negative number, like the square root of negative 9, we can't do it because no number multiplied by itself will give you a negative. Okay, you're either going to have positive 3 times positive 3, and that's going to equal 9, or you have negative 3 times negative 3, and that's going to equal 9. But notice that the products are never negative, it's always positive. Because two positives together gives you a positive, two negatives multiplied together gives you a positive. So how are we going to work through finding negative square roots? Well, the first thing we're going to work through is we're going to talk about what exactly I is. Some of you already know, some of you are kind of confused with it, some of you don't know at all. I is equal to the square root of negative 1. So we're going to use that when we start to work on breaking down square roots of negative numbers. Well, if the square root of negative 1 is what I is, I squared, we're just going to kind of write it out for a second. I squared is going to be equal to I times I. We know that anything times itself can be rewritten, can be rewritten as that thing times itself twice. Well, we just said that I was the square root of negative 1. So this is really the square root of negative 1 times the square root of negative 1. Some of you might not actually understand, but when we talked about it up here, that the square root of something and squaring something are actually opposites. So when we talk about multiplying this square root of negative 1 times square root of negative 1, this is really the square root of negative 1 squared. This square and the square root that's in here are actually going to cancel each other out. Okay? So if they cancel each other out, I'm strictly just left with negative 1. We'll talk a little bit more about that later. But understand that I squared is always going to be negative 1. We are going to start working on evaluating I squared. I squared will never be in your answer, ever, ever, ever. And you'll see what I'm talking about later when we get to multiplying complex numbers. So you're just going to see how this fits in with what we've been talking about. Let's go into our first example, the square root of negative 121. I taught you two different ways. We talked about two different ways, rather. Of simplifying radicals. One was split the radical, where we split it into two separate things. The other one was prime factorization. You're going to see me split the radical here for a specific reason. I don't want that negative. I want that to be gone. I want to have a positive number under the radical. So watch what I'm about to do. I'm going to split the radical, and I'm going to do the square root of negative 1 times the square root of 121. Now 121 is a positive number. I can work on simplifying it the way that we were doing last week. The square root of -1, we just saw, if you go back up, the square root of -1 is I. So I'm going to rewrite this as I. Anybody know what the square root of 121 is? It's one of your perfect squares that we're working on learning. You should be memorizing these. This is 11. Well, anytime, and this doesn't matter whether we're dealing with complex numbers or just regular variables or anything like that, anytime we have a variable and a number, the number, which is what we call a coefficient, is always going to come first. So the answer to that one is negative, or is 11i. Really, anytime you see a negative under a radical, you can just go ahead and pull out I. You don't have to show that first step that I did. So when I'm looking at my second example, and let's just kind of separate these, I'm not even going to write that square root of negative. I'm just going to go ahead and I'm going to say that this is really I times the square root of 28. Then I can just strictly work on what's under the radical. I don't have to worry about anything else. Okay? I don't have to worry about that negative. It's already there. It's accounted for. I can just work on the 28. And 28 is not a perfect square. So if we split this up, 28 is really 4 times 7. And 4 is a perfect square. 4 is 2. We can't do anything with that 7. Exactly like we did on the first example, I always want the number before the letter, so I'm going to write this as 2i squared. So that's the only way that I is going to come into what we have talked about previously. Okay, if you're working on square rooting a negative number, pull I out and then simplify the way we did the other day with just the positive. So what about when we're looking at operations with these? Okay. This is no different than any other letter. If this was A, you would say 5 times 2, okay, that's 10, carry the A down, 10A. It's no different here. 5 times 2 is 10, carry the I. When you have I by itself, it's no different than any other variable. It could be X, it could be A, it doesn't really matter. It's no different. The only time that this is different is stuff like on this next one. So if this was X, we would say, hey, negative 3 times 2, it's negative 6. And we multiply our two letters together. If it was X, we'd say X squared. If it was A, we'd say A squared. If I was the I squared. No change there. Okay, the actual operation doesn't change. The only thing that changes here is that we never, ever, ever are going to have I squared in an answer. If you look back up, you see that I squared is negative 1. So really what we have is negative 6 and negative 1. Because there's no operation between them, we know that it's multiplication. Well, what is negative 6 times negative 1? Positive 6. So anytime you see I squared, you're always going to want to rewrite it as negative 1 multiplied by whatever you had before. Okay? We're never going to leave I squared in our answer. And you can pause this video, go back and re-look at it, listen to things again as many times as you want. Okay, it's not really going to make a difference because we're in video. We're great. There's no stopping the class. Okay. A complex number is a combination of a real number, and I'll explain what that means in a second, and what we've been talking about, an imaginary number. Meaning there's going to be I. Okay, imaginary numbers always have I. Real numbers are exactly what we've always dealt with, just numbers that don't have I, they don't have a variable. They're just normal numbers. They can be positive, they can be negative, they can be fractions, they can be decimals, doesn't matter. They just don't have I with them. And it's going to look like this. Any complex number you deal with is going to look like that. Where A represents our real number. Easy things like 1, 2, 5, negative 12, normal numbers. BI is going to represent our imaginary number. You saw imaginary numbers up in here with these examples. All of these are examples of imaginary numbers, with the exception of the last one where there is not an I. That's an example of a real number. So to get into operations, it's really no different than what we do on polynomials, and we're just combining like terms. It's really all we're actually doing here. It's nothing really different than what you're used to. So you can add and subtract complex numbers in the same way you have combined algebraic expressions. Keep your real terms and your imaginary parts separate. I'll explain what that means in a second. Now, they're going to be together as far as they're all going to be in one mathematical sentence, but they're going to be separate as far as you cannot combine 2i and 4, for example. Okay, those two things are not like terms. So we're just going to jump right in. The way I did this with my first class, I did a lot of color coding and things like that. You are welcome to just circle things, which is what I'm going to do here. I'm just going to start with looking for things that match. So the first thing I see is that this -2 is a real number, and this 1 is a real number. So I'm going to combine them, because if you look up a plus or minus bi, your real number always comes first. So I'm going to handle the real number first. And I'm going to put it together, whatever sign is in between. Okay? So I've got -2 plus 1. Now that's -1. Then I'm going to look at my imaginary term, 5i and -7i. Keep the sign. 5i plus -7i. That's going to be -2i. It's not I squared because I'm adding. If you're adding or subtracting, you're not going to create an I squared. Only if you multiply do you create an I squared. There's my final answer. Over here, same thing. Now, a couple people are going to want to, and the way I prefer it is if you were to distribute this negative and rewrite it as an addition problem instead of a subtraction problem. So that's the way I'm going to show it. Some of you are going to be able to, if you do what I did the first example and you kind of bounce off the sign, you might be able to do this without distributing. I always think distribution is going to be the safest option. So I'm just going to distribute the negative. When I distribute, the negative becomes addition, the subtraction becomes addition, and every sign that I distribute the negative to changes. So it was -1, now it's +1. It was +2i, now it's -2i. Now we're dealing with an addition problem, the exact same thing that we were dealing with in the first example. We can work on just combining what terms. Start with our real terms. 4 and 1 are 2 real terms, and we're adding them together. So 4 plus 1 is 5. And I've got 6i and -2i from the imaginary terms, and adding them together. So I've got 6i plus -2i. That's +4. It really is that simple. It's just combining your like terms. Again, though, if you're looking at a subtraction, I would distribute the negative and change it to addition. Okay, it's just going to make it a little bit easier on you. You're not going to risk adding when you're supposed to be subtracting or something like that. I'm going to let you work on these two examples on your own. You can pause the video for a second, work them through, and then come back and check your answers. Yeah. So here are the final answers. We would have combined the 7 and we would have distributed that negative, so we would end up having 7 added to -1, to 6, -2i, added to -3i to get -5i, 2 and -3, shifting over to the next example, would combine to get -1, 5, and -2i, 5i and -2i, I'm sorry, combined to get +3i. So if you had different numbers than this, you might want to go back, check your work, and see what happened. So let's move on to multiplication. It's the last thing we're going to cover today. When you multiply complex numbers, use the blank method that you're already familiar with. Okay, well, I've already told you that this is kind of like polynomials, so you might not remember the two methods that you learned to multiply polynomials. You learned full and you learned box. I do box just because I think it's really organized. And sometimes students struggle a little bit with FOIL because they don't see it as this distribution. So I do box just because it's super organized, and there is actually a method when we get to factoring that I do the box in reverse, so I want to make sure that everybody's familiar with the box. Then combine like parts. However, you must simplify further by replacing I squared with, well, think back to the first page of these notes, I squared is equal to -1. And you saw how we evaluated -1 for I squared in that fourth example. Okay, nothing's going to change here. We're going to multiply things out, we're going to combine like terms, and then just the last thing we're going to do is go ahead and anywhere we see I squared, we're going to replace it with -1, and then we might have to combine like terms again. So let's take a look at this first one. And we're going to do the same thing. I'll do these two with you, and then I'll pause the video, you'll pause the video, sorry. Get the answer for the second two, and then check your answers. So this video is only going to be about 20 minutes, which is like a little mini lesson for us before you get started on your assignment. So when I do the box, I always hit the first one and I put it down the side. It will work as well if you put it across the top, it really doesn't matter. But I always put it down the side. If you're foiling, keep in mind, first, outer, inner, box. If you're not foiling, then you're doing box method with me. Now, notice how I kept the sign. That 3i was already negative, and I kept it negative. Don't change the signs or anything. Okay, this is not going to be any kind of distribution or anything like that. And I'm just going to go through those of you who need a refresher on the box. When I'm looking for this one right here, I look up, and I look to the left, and I multiply those things together in order to fill in the box. So let's get rid of everything I just drew. So I've got 9 times 2, which is 18. Then when I move over, I just go up to -3i, and I go to 2. So -3i times 2 is -6i. Then I've got 4i times 9. That's 36i. And I've got 4i times -3i. Well, 4 and -3 is -12, and I times I is I squared. Now, I like box. One big thing is because I can see my common terms really easy if I just look along the diagonal. And I can go ahead and combine them before I write them down. I don't need to write it down and then combine and then go back and all this kind of stuff. I can combine it as I'm rewriting the problem. 18 doesn't have any kind of like term, so I'm just going to write it. I've got 36i and -6i, and that comes out to 30i. And I've got -12i squared, so already that I'm bleeding into the next problem. Okay. So I've already combined my like terms. I don't need to check for that again. I'm on to that last thing that says, however, you must simplify further by replacing I squared with -1. I see I squared is attached to -12, so I'm going to come in and do like this. And instead of I squared, the exact same way we did on that fourth example up at the top, I'm going to rewrite I squared as -1. I'm using multiplication because there was no sign between the 12 and the I, so that means multiply. What is -12 times -1? It should be saying +12. The last step is to do one final check for common terms, and you'll see that 18 and 12 are like terms, which means they can be put together. 18 plus 12 is 30. Notice my real number is up front. My real number is always going to be up front. Okay? Number without the I always goes up front for your answer. Do not put 30i plus 30. This is 30 plus 30i. So let's come over, let's try the next one. Again, you can pause, go back, watch this again at any point. I'm going to do box. If you're doing FOIL, that's fine. Again, keeping any signs that happen. So since that -6i was there, I'm going to keep that negative. And I'm just coming in and multiplying. 1 times 3 is 3. 1 times -6i is -6i. 4i times 3 is 12i. 4i times -6i is -24i squared. Sorry, it's not printed in Again, I see these common terms happening in my diagram. So as I rewrite, I'm going to combine them. 3 doesn't get combined with anything. There's nothing else for it. 12i and negative 6i comes out to positive 6i. And then finally, negative 24i squared. Last up, same as the first example, I'm going to come in and where I see that I squared, I'm going to get rid of it. I know that I squared is really equal to negative 1. And then you evaluate. And some of you are going to be able to kind of skip this stuff. Some of you are going to be able to fill in the box, look at it, know that negative 24i squared is going to turn into positive 24. And you already see those like terms. Some of you are really only going to be able or going to have to do the box, and that's going to be the work, and you're going to get an answer out there. That's fine. This will go faster once you get more comfortable with it. That's going to combine these two like terms. 3 and 24 is 27. There again, there's 6 of them. Again, your real number is always going to be up front. Okay. If you're doing FOIL, you should be ending up with the exact same answers that we're getting. I like box again, just because it's a little more organized and it really kind of hits just in the right spot for my visual learners. So if you want to pause the video and take a stab at these two problems, I'm going to pause mine, write the answers, and then you can check your work. All right. So here are our answers for our last two problems. We should have been good. If not, if you didn't get these answers, go back, check your work. If you're really struggling on box, try FOIL. If you're really struggling on FOIL, try box. If you need to work with each other, if you just can't figure it out and somebody else got the answer, if you want to go kind of check with them what's going on, how they're doing it, let's figure out what's going wrong. But those are your notes today, guys. You do have an assignment that you should already have in front of you. It's called Riddle Time. It's got mice on it. It's going to ask you to go through, perform some operations, match some numbers and letters, and come up with an answer to a little joke type thing. Make sure that gets turned into the sub before you leave today. And I'm going to take that as a classwork grade, which means it cannot be turned in late before you leave today. And let me know how everything went. Have a good rest of your day, guys.